Hello friend, myself Jitendra Kumar. I am taking electrical machines for the mechanical engineering students. In the previous lecture, we are discussing various parameters which are related with the electrical machines of DC or the AC types of machines. In the previous lecture, we are discussing about the electrical induction machine operation as a transformer. Now we are discussing about the equivalent circuit diagram of the electrical AC machine. An induction motor is a well-known device which works on the principle of a transformer. So it is also called as a rotating transformer. That is, when an EMF is supplied to its stator, then as a result of electromagnetic induction, a voltage is induced in its rotor. So an induction motor is said to be a transformer with rotating secondary. Here, primary of transformer resembles stator winding of an induction motor, and the secondary resembles with the rotor winding of the induction motor. The induction motor always runs below the synchronous or full load speed, and the relative difference between the synchronous speed and the speed of rotation is known as the slip, which is denoted by S. S is ns minus n upon ns, where ns stands for the synchronous speed and n will stand for the speed of the rotation or the rotor speed, where ns is synchronous speed of rotation, which is given by ns equal to 120 f by t, where f is the frequency of the supply voltage, t is the number of poles of the machine. The equivalent circuit of an induction motor shows the various parameters of the machine, such as its ohmic losses and also other losses. The losses are modeled just by inductor and the resistor. The copper losses are occurred in the winding, so the winding resistance is taken into account. Also, the winding has inductance, for which there is a voltage drop due to inductive reactance, and also a term called power factor comes into the picture. There are two types of equivalent circuit in case of a three-phase induction motor. Exact equivalent circuit diagram of the transform of induction motor, it will be like this. Over here we are saying that the R1 and the X1 will stand for the stator winding, equivalent, and this RC and XM, it will be indicated as the core of the machine, core of the machine at the stator side, and it will be indicated over here because the EMF will be voltage. So on the system will be the equivalent. So it will be indicated in the parallel format, and the resistances and the reactance are shown in the parallel in a series format. And there is a process of the electromagnetic induction from the primary side towards the secondary side, or from the stator side towards the rotor side. So this part will be indicated as a rotor, where rotor reactance, it will be based upon the slip, but whenever we have to just vary about this the load, so load will be varied, then the reactance will be changed. So we are indicated like the R2 will be upon S. Here R1 is winding resistance of the stator, X1 is inductance of the stator winding, RC is the core loss component, XM is the magnetizing reactance of the winding, R2 upon S is indicated as the power of the rotor, which includes output mechanical power and copper loss of rotor. If we draw the circuit with referred to the stator side, then the circuit will look like this, where R1 JX1 it will be over the primary side, RC and JXM it will be also placed over there. But the right hand side component will be transformed from that side towards the primary side. So it will look like the R2 dash, JX2 dash, R2 dash into 1 upon S upon S, because we are converting all the components which will be adjacent over the right hand side, it will transform towards the left hand side. So this notation dash, this dash, and this dash will be represented over here. Here all the other parameters are same except R2 dash is the rotor winding resistance with referred to stator winding. Similarly, X2 dash is the rotor winding inductance with referred to stator winding. R2 into 1 upon S is the resistance which shows the power which is converted to mechanical power output or useful power. The power power dissipated in that resistor is the useful power output or on the soft power. Approximate equivalent circuit of the machine. The approximate equivalent circuit is drawn just to simplify our calculation by deleting one node. The sun branch is shifted towards the primary side. This has been done as the voltage drop between the stator resistance and inductance is less, and there is not much difference between the supply voltage and the induced voltage. However, this is not appropriate due to the following reasons. First, the magnetic circuit of induction motor has an air gap, so exciting current is larger compared to transformer, so exact equivalent circuit should be used. The rotor and stator inductance is larger in case of the motor. Third one, in induction motor we use distributed winding. Fourth one, this model can be used in proximate analysis, has to be done for larger motors. For small motors, we cannot use this type of arrangement. So next, then there will be the power relation of equivalent circuit. Input power we stated 3 times V1 I1 cos theta, because the three-phase supply will be given, so 3 times of the power will be there. Where V1 is the stator voltage applied, I1 is the current drawn by the stator winding, cos theta is the stator power factor parameter. Then there is a rotor input power, and rotor input equal to power input minus stator copper and iron losses. So that stator copper loss, rotor copper loss will be the slip in times power input to the rotor, and the developed power is 1 minus S times rotor input power. These are the equivalent circuit diagram and the various equations which will be associated in case of the induction machine. So we are just moving over the other parameters of the induction machine in the later lecture. Now we are ending over the equivalent circuit diagram of that three-phase induction motor. Thank you.